Okay. You can use the distributive property to multiply a monomial by a polynomial. We're going to take this binomial here, 3x plus 1, and we're multiplying it by this monomial, 2x. Distributing it through, multiplying it to each part of it. Okay? So, if we did that, what do we get here? 2x times 3x, 6x squared. 2x times 1, 2x. We've distributed it through. And here they're showing you a visual representation of it. This is 2x, and this is 3x plus 1. And if you do x times x, what's x times x? X squared, right? This is a square of side x with side length x, right? So x times x, x squared. This x times this x, x squared. This x times this x, x squared. This x times this 1 times x is x. Okay? So we've got 2x times 3x plus 1, and we've got 1, 2, 3, 4, 5, 6x squared, and 1, 2, 2x. These are algebra tiles. These are area tiles, okay, or area models. And you will use these in your IXL to kind of, or one of your IXLs to practice this. It'll start to make sense to you as you do more, okay? So it says here, you can show why multiplication makes sense using the area model at the right. Now, let us move on and see what else they have to say about this. Okay, so what's the simpler form of this? What we're really going to do is we're just going to distribute this times this times this, and this times this. Okay, so they wrote it out in pieces right here. They're saying what they asked us for here. By the way, these are just multiple choices. We'll see which one's right in a second. They're going to say this negative x cubed times this term, 9x to the fourth, is there. This negative x cubed times this negative 2x cubed is right there. And this negative x cubed times this positive 7 is right there. Okay, so simplifying them, you get, well, what's x cubed times x to the fourth? Remember, you add the exponents when you're multiplying like that for a 7. And negative times 9 is negative 9, so negative 9x to the 7th. This negative times negative gives you a positive. The 2 is the coefficient. There's a coefficient of 1 here, really. 1 times 2 is 2. And then x cubed times x cubed, x to the 6th. So negative times negative is positive, 2x to the 6th. And right here, negative x cubed times 7 is negative 7x cubed. So which one is that? That is this one right there, D. Okay? Here's your got it problem. What's the simpler form of this? You are going to pause the video now, come up with your answer, and then unpause it when you have your answer to check against mine. Do that now. Pause your video. Okay, so all I'm going to do is do it like this. 5n times 3n cubed. Well, what is 5 times 3? 5 times 3 is 15. And what is n times n cubed? It is n to the fourth. Now I'm going to do this right here. What is 5 times negative? Really, it says negative 1 there. Okay, 5 times negative 1, negative 5. And what is n times n squared? N times n squared is n cubed. And we're going to do this right here. 5n times 8. What is 8 times 5? It is 40, positive 40. And there's only one single n in there. And that is what you get, my friends. Nice. Fairly straightforward, I hope. Okay, let's keep going. Okay, so just like in the last slides where we distributed a monomial into a polynomial, we can pull one out as well. It says right here, factoring a polynomial reverses the multiplication process. When factoring a monomial from a polynomial, the first step is to find the greatest common factor. So if you look at this, they're saying find the greatest common factor. What's the greatest common factor of these three terms? Okay, you can explode this out into its prime factors. 5x cubed is just the same as 5 times x times x times x. Okay, 25x squared is just 5 times 5, that's 25, and x times x, that's the x squared. 45x. 45 is 9 times 5. Here's 3 times 3 is the 9 times the 5. This is broken down into primes. Times x, because there's an x on there. Okay, so what's in common? Well, they all have one 5 right there in red, and they all have one x there in blue. 5 times x, or 5x, is the greatest common factor. Okay? You'll get way better at this really fast, but I'm going to write it out for you at the start. Do this got it problem, see if you understand what was going on there. Pause your video right now and then unpause it when you have an answer to check against mine. But start by getting your best answer down on paper first. So pause the video now. Okay, so I'm going to take this first term, 3x to the fourth, and say that's just 3 times x times x times x times x, right? Minus 9x squared. 9 is just 3 times 3. And x squared is x times x. That's 9x squared right there, okay? And then minus 12x. What does that look like? Well, that's minus 12 is 4 times 3, and the 4 is 2 times 2. I put them in order. So 2 times 2 is 4, times 3 is 12. That's times x, okay? And now we're trying to figure out, is there something that's in every single one? Well, each one has a 3, and each one has a single x. And this has more than just a single x, but this one doesn't, so you can't do something with those since this one can't match that action and do the same thing. So what do we get? Okay, the greatest common factor is simply 3x. That's the greatest thing you can divide out, okay? We're going to also then say what's left later on, and we'll essentially, we'll do that in just a moment, and what we'll essentially be doing there is saying, okay, once you pull that 3 and that x out, what do you have left? Okay. Oh, that's the negative, that stays there too. But we'll do that in the next slide, so let's follow with me. Okay, so this is our last problem in this set. What is the factored form of 4x to the fifth minus 24x cubed plus 8x? So what they're asking us to do is not just identify the greatest common factor, but also see what's left. So we take each part and we expand it. 4x to the fifth is just 2 times 2 times x times x times x times x times x. You can multiply that back together to make sure that it becomes that. Okay. 24x cubed, 2 times 2, 4 times 2, 8, 8 times 3, 24, there's the 24, and there's the x cubed, x times x times x, okay? And here, 8x is just 2 times 2 times 2, that's the 8 times x, okay? What do we then identify as being common in all of those? Well, we've got a 2 on each one here. We've got another 2 here on each one, and of course we've got another, in this case, x on each one. Okay, so 2 times 2 is 4, times x is 4x. 4x is our greatest common factor. So if you were to pull that out of each one, and actually let me do just a little bit better job of marking it off, okay? If we did that on each one, we say, okay, we've got the 2 from this. We've got the other 2 here. And we've got that x on each one. And so that 4x sits out front. And then the question is what's left? Well, what we really want to look at then is all of the remaining pieces. If you multiply them back together, what do you get? These remaining pieces from that first term, x to the fourth. And that's what you see right there. Okay. For here, you've got these pieces right here for the coefficient, and here's the variable. 2 times 3 is 6. X times x is x squared. 6x squared. Okay? But that was subtraction, so that negative has to stay there as well. Okay? And here, what's left from this 8x when you divide out 4x, it's just the 2, and it's right there. Okay? So you get 4x times this whole trinomial, and you can check it and put it all right back in, say 4x times x to the fourth would be 4x to the fifth. 4x times negative 6x squared, that 4 times negative 6 is negative 24, and that x times x squared is x cubed. And this 4x times 2 is 8x. And if you did that right, when you put it back together, you should get back to your original polynomial, which you had at the start. And we do. Okay? So here's your got it problem down at the bottom. You're going to give the factored form of this polynomial. And then it says for reasoning, right here, what is this? Written as the product of a polynomial with positive coefficients and a monomial. The monomial that we're going to factor out has to take the negative out of it. Okay? So if you take the negative for each one and you put it as part of the monomial, what is left as a polynomial on the inside of the parentheses that all have positive coefficients. Do those two pieces, pause it right now, do those two pieces, and then unpause it and check your answer. Okay? Pause it right now for you to answer this got it problem. Okay, so the first part of this is what is the factored form of 9x to the sixth plus 15x to the fourth plus 12x squared. And what I'm going to do is I'm just going to actually look at, I'm going to start to do this in my head a little bit. I'm going to say, what is the common factor of 9, 15, and 12? Okay, the biggest number that I can divide them both by. And the biggest number that I can divide them both by is actually a 3. Okay, and I could say, okay, well, if I divided that 9 by a 3 to write down the first part of this term here, right? That 9 divided by 3 would leave me with a 3 on the inside. Okay, what about for this term? What is this 15 divided by that 3? Well, that would be a 5. I'm going to put that here. And what is this 12 divided by that 3? 12 divided by that 3 is a 4. I'm going to put that here. Okay? And the last thing that I'm going to do, the next thing that I'm going to do is I'm going to say, what is the most number of x's that I can get equally from each one? Okay, this has 6, but this one only has 4, so we couldn't give 6. And this one only has 2. This one, we're limited by the fact that this one can only give 2. So this x squared, those 2 x's are going to come out front. Those are going to get factored out. And so that means that here, two of these 6 x's that are being multiplied together are out front now. So how many are left? If there's 6 of them multiplied together, but 2 of them are out front, there's x to the fourth left there. Okay? We need to take this sign and put it there. And again, we factored out 2 x's, so if there was x to the fourth here, and we took 2 of them away, how many would be left? There'd be 2 of them left, x squared. Okay? And we take this plus, addition sign, put it there. And notice that we took, there's 2 x's here, and we took both of them and put them here. If we do this right, then at the end of it, one of them won't have any x's left, right? Because if they each had x's left, that meant we didn't pull enough from them, and they each could all give more. So that's what you get, and you can actually check that by distributing this back through and seeing that you get, yep, 9, x to the sixth, yep, right there. 3 times 5 is 15, x to the fourth, yep, that's right there. And 12, x squared is right there, okay? And finally, what is this polynomial the wording is a little difficult, and that's why I wanted to talk it out with you. Written as the product of a polynomial with positive coefficients. Notice the polynomial's inside, and they want you to have positive coefficients. Since they all have negative ones right now, that means you want to pull the negative out front and have that for this one, okay? So what can we pull out of here? Well, we know that for this one, since every term is negative, we're going to pull a negative out for that monomial that we're factoring out. Okay, what's the biggest number that we can divide 6, 18, and 12 by? It's actually 6. We can divide a 6 out of there. And how many can they all each equally give? This one's got 4 x's being multiplied together. This has 3 x's being multiplied together. This one's only got 2. We're limited to this one because it's the most that it can give is 2, so they all give 2. So we have x squared that gets factored out. Okay, so what is negative 6 divided by this negative 6? It's just 1, and so we're going to have a coefficient of 1. But we won't write it because there's 4 x's here, 2 of them around here, so we've got 2 of them inside still, x squared. We don't need to write 1x squared, we just write x squared. And of course, as you can see, this times this is negative 6x to the 4th, just like we have here. Okay, let's do the next one. We're going to take this term right here, divide it by negative 6, because that's what we divided out. What is this divided by negative 6? Negative 18 divided by negative 6 is positive 3. And how many x's are there? There's 3 x's being multiplied together, x times x times x, for x cubed. And 2 of them are here, so the third one is going to be following it. Okay? And finally, we say this is negative 12 here. If you divide negative 12 divided by negative 6, negative 12 divided by negative 6 is positive 2. And if you have 2 x's out here and this only had 2 x's total, there's no more x's left for here. So you just close that back up. And that fits with what it says. It is the product. These are being multiplied. Oops. This polynomial and this are being multiplied. Okay, it's a product of a polynomial, this, with positive coefficients, positive 1, positive 3, positive 2, and a monomial, and this is the monomial, and the negative is there. Okay, that's how you do it. This video took a while, but I think that it's fairly straightforward as long as you understand how to take something like this and break it up into its prime factors. If you can do that, then you can see what they all have in common and identify the greatest common factor, and then see what's left. Okay, good luck.